petroleum industry is a vital sector that plays a significant role in the global economy. It actually involves the exploration, the production, refining, and distribution of petroleum products. So, we could just consider some of these characteristics of the petroleum industry. Here we have complexity. The petroleum industry is actually a complex matrix or a system involving various processes. We have various processes, cracking, desulfurization, distillation, all of which are various processes from exploration to end-use products. Now, global distribution, you could actually understand it is important for you to know that petroleum resources are found globally with major producers including Saudi Arabia, Russia, and the United States. So we have other continents or other countries that also produce petroleum. And then we have variety of products. Petroleum is refined into various products, including diesel, gasoline, jet fuel, lubricants, and petrochemicals. Petrochemicals are chemicals obtained from petroleum. All right. So we have energy density. Petroleum products have very much high energy density, making them even efficient energy sources, which we can use for various end uses. So they are actually non-renewable. It's a non-renewable resource with finite reserves. That means it doesn't get exhausted. Okay. So we have exploration and production as one of the characteristics of the petroleum industry. Exploration involves finding new reserves. Where are the deposits? Where can they be found? Where are the rock-forming petroleum deposits? Okay, while production involves extracting petroleum from the ground, from dead marine organisms, the fossils. So another characteristic is the refining and processing. Crude oil is actually refined and processed into various products using chemical reactions. We'll be looking at these chemical reactions: alkylation, polymerization, isomerization. All of these are chemical reactions and separations. Okay, distillation is also a separation method employed. So another characteristic is environmental impact. The petroleum industry has very much significant environmental implications, including the release of greenhouse gas emissions and oil spills, which we've actually discussed previously. So, and it is of economic importance. The petroleum industry is a significant contributor to the global economy, with petroleum products driving transportation, commerce, and industry. And there has been a constant evolution in the petroleum industry. The industry continuously evolves with advancements in technology, changes in global demand, and shifting environmental regulations. So these are the few characteristics of the petroleum industry we would be considering. So the scope of the petroleum industry is divided into three. We'll be looking at the upstream, the midstream, and the downstream. The upstream has to do with the exploration and the production of oil and gas, which actually entails identifying the areas that are oil bearing, by using different methods such as seismic surveys and drilling to actually ascertain for the presence of oil and gas. And the production has to do with extracting the oil and gas from the reservoir. We've talked about that before. And the midstream entails basically the transportation of oil and gas, while the downstream has to do with the refining and marketing of petroleum. Crude oil is extracted from the production stage from the upstream, and then it has to be processed into usable products in the downstream, that is refining. And refining itself involves various physical and chemical processes to separate the different components of crude oil and convert them into usable products, to meet end use. Now we'll be looking at the physical and chemical outlay of refinery operations, and then the physical outlay, we'll be looking at some of the various units operations that are being carried out in a petroleum industry. So we have one of the physical outlay is the use of a desalter. A desalter, usually there are salt content in crude oil and they vary depending on the source of the crude oil. Now, desalting is carried out to remove impurities, especially salts and water, from the crude oil prior to distillation. Now we have the crude distillation unit, which comprises of an atmospheric distillation column, side strippers, heat exchanger network. It also have a field desalter and a furnace as main technologies, which enables the separation of crude into various products or fractions. Now, the atmospheric distillation units in the crude distillation units operates at atmospheric pressure and higher temperatures to separate lighter fractions like gasoline and diesel. Now we have the vacuum distillation units, another physical outlay. The VDU, the vacuum distillation unit, operates at reduced pressure and lower temperatures to separate heavier fractions, producing heavier fractions like vacuum gas oil, VGO, and lubricating oil. Now you have to note that crude oil is separated in a distillation unit, be it the ADU or the VDU, that's atmospheric distillation and vacuum distillation unit, through a process known as fractional distillation, which involves heating crude oil at elevated temperatures in a furnace or heat exchanger. And once the crude oil is heated, vaporization occurs. That is the first thing that happens. Now, when the heated crude oil is fed into the distillation column, it vaporizes, okay? So it has to be heated, then fed into a distillation column or unit where it vaporizes. And then condensation occurs. Now, as the vapor rises, it cools and condenses into a liquid on each tray of the distillation unit. Now, what occurs next is separation. Now, the condensed liquid is then separated from vapor, and the process is separated on each subsequent tray. What happens next is fractionation. This process occurs due to differences in boiling points. So based on their boiling points, the crude oil fractions are separated into the various collecting trays and sent for further processing. Now, the distillation column essentially yields gasoline, naphtha are just hydrocarbon ranging from C5 to C12. Kerosene is there, diesel, VGO, and that's the vacuum gas oil, and residual fuels. These are some of the yields from the distillation column. We also have a thermal cracker. The thermal cracker involves chemical cracking process followed by separation, which takes advantage of their boiling point differences to yield desired product. Then we have a component which is also a physical outlay called a hydrotreater. The hydrotreaters are used for sulfur removal such as thiophene, sulfides, sulfur mercaptans, also for nitrogen removal where nitrogen is typically transformed into ammonia gas. It's also used for oxygen removal where oxygen is reacted with hydrogen and eliminated as water. Olefin removal where the olefins are transformed into stable paraffin hydrocarbons. And also the hydrotreaters are used for metal removal where metallic components are removed because they can cause deposits on catalysts and in engines, okay, which could actually lead to knocking or maybe the poisoning of the catalyst. So the metals are actually being removed. Now we have another component called the FCC, which is the fluid catalytic cracker. It converts heavy, high boiling point hydrocarbons to alkene gases, and it breaks large hydrocarbons into smaller molecules through catalytic cracking, producing high octane components of blended gasoline after the removal of sulfur compounds. The removal of sulfur compounds is a function of the hydrotreaters. So we have the separators. Here the gas fractions from the various units previously actually needs additional separation. It requires stage-wise separation of the gas fractions. So we have the C4, C3, C2 separators of gas fractions to yield desired products. Then we have the naphtha splitter. The naphtha splitter consists of a series of distillation columns which enables the successful separation of light naphtha and heavy naphtha from consolidated naphtha stream obtained from various other units previously. So we have a catalytic reformer. The catalytic reformer actually converts low octane naphtha into higher octane reformate products for gasoline blending and aromatic rich reformate for aromatic production such as benzene, toluene, we have all those. So that is the work of the catalytic reformer. Major catalytic reforming reactions in the catalytic reformer, one of which is the dehydrogenation of naphtha to convert them into aromatics. Then we have the dehydrogenation and aromatization of paraffins to aromatics. And then finally we have the hydrocracking of paraffin into smaller molecules. Now the octane number is just but a measure. We'll be looking at that. So essentially the essence of catalytic reforming is to increase octane number. So the octane number is a measure of the performance of an engine or an aviation fuel by measuring the rates of isooctane in the gasoline structure. So essentially the higher the octane number, the more compression the fuel can withstand before detonating or knocking or igniting. So fuels with higher octane number are used in high performance petrol engines that require higher compression ratios, while fuels with lower octane number means higher N-heptane rates. So isooctane has an octane number of 100 as a designation, while N-heptane has an octane number of 0. So now we also have one of the process and a physical outlay where it occurs is the alkylation and isomerization. Alkylation combines light hydrocarbons to yield high octane components of gasoline. And alkylation has to do with the reaction of olefins and isoparaffins to yield mixture of heavier hydrocarbons. Now, isomerization essentially converts N-butane to isobutane for use in the alkylation process. Now we also have the desulfurization. Desulfurization processes such as hydrotreating and hydrocracking convert sulfur compounds into hydrogen sulfide, which is then removed and converted into elemental sulfur or sulfuric acid, thereby producing cleaner fuels, because we don't need sulfur in crude oil, though it has one or two major impacts. It causes air pollution. It tends to corrode equipment and some infrastructure, and it also tends to poison the catalysts that are being employed in refining. Poisoning means to halt or to reduce the efficiency of the catalyst. And then we have some steam reforming major reactions. First off, there is the pre-reforming, where hydrocarbons such as the C3, C4, and the naphtha. I said earlier, naphtha has to do with the C5 to C12 hydrocarbon range. So these higher hydrocarbons are broken down into methane for more efficient reforming. That is pre-reforming. Then we have the methane steam reforming, where the methane reacts with steam to produce carbon monoxide and hydrogen gas. And then we have the water gas shift reaction, where the carbon monoxide that has been formed in the methane steam reforming reacts with steam yet again to produce carbon dioxide and additional hydrogen gas.